today we're going to have a little recap about functions. First of all, a function is a mathematical rule where for each input there is exactly one output. So for shorthand, it's a mathematical rule. Functions are different than relations. Be careful with that. Let's talk about the inputs. The stuff that goes into your function is also called the domain, and it would be the set of all values that you input, or in this case, the set of all values of x. Now, it doesn't have to be x. You could use different letters, but let's just start with x and y. The output is also known as the range, and that's the set of all values for which x is defined. That means that when you put an x value in, you do get a value out, also known as y, so all of the y values. Functions can be displayed in 4 different ways. So they could be a sentence, they could be a table of values, they could be a graph, or they could also be and to tell if you have a function, your function, if you graph it, your function has to pass the vertical line test. Vertical line test. Which basically means if you have something that looks like that, if you take a vertical line anywhere, it will only cross the function in one place. That's because for each x, there is only one y value. So if I put in, x equals -2 over there, I get a particular y value. If I put in x equals 1 over here, I get a particular y value. Now notice, looking at this diagram, and again, I'm just making up these numbers, but if I put in -5 for x, it looks like I get 0 for y. And if I put in 1 for x, it looks like it gets 0 for y. So it's okay that y is the same value for 2 different x's, but x can't have 2 y values that are the same. So for example, if we look at this, this is not a function. This is what's called a hyperbola. But notice it fails the vertical line test because these places you would have an x value, I don't know, making it up, let's say an x value of 2 and 4, and then an x value of 2 and -4. So this is not a function. Okay, there's also function notation. So in function notation, there's x. X is your input. There is f of x. That is your output. And then you have an equation, which put those things together. So f of x equals, in this example, x squared plus 2. So this is telling us that we're going to put some number in there and square it, and then we're going to add 2 of it. So that's our 2 to it. So that's our mathematical rule. Square a number and then add 2, and that will give us our result. Recall that when you read this, this is read as f of x. It's not f times x. Those are very different things. Also recall that f of x equals y. So f of x is the same as y. A lot of times you'll see things written as in like y equals f of x, and then they'll explain what f of x is. And that's just saying that there's an equation somewhere and it's going to follow this function. Oftentimes you will be asked to evaluate a function at a particular value. So given this function, f of x equals x squared plus 2, we've got 3 examples here, and we're going to be asked to evaluate it when at f of 0, f of -1, and then also when x equals a. So to evaluate it, all this means is that the thing that's here is the x value. So we're just going to plug that in for x and then perform the operations. And remember, we already said when we looked at this one that the rule for this is like square the x value and then add 2 to it. So here we're going to square 0 and then add 2 to it. So we know that f of 0 is equal to 2. In this next example, our x value is equal to -1, so we're going to substitute it in wherever there's an x. So -1 squared plus 2. If you square -1, you get 1, plus 2, you get 3. So we would have f of -1 equals 3. Recall that this is now a coordinate pair, so -1 is the x value and 3 was the y value. So -1 was your input, 3 was your output. If we go back to the first one, 0 was your input, 2 was your output. So 0 is x and 2 is y. Okay, if we come to our third example where x equals a, here we're just substituting the a value for the x value. And again, we're just following the rule of the function. So it says f of x equals x squared plus 2. If we want f of a, then that means we're going to take whatever's in that parentheses, square it, and add 2. And that's it. That's all you can do. So here our coordinate pair would be a, because that was our input, and the y value is this expression, a squared plus 2, because that's our output. Sometimes functions don't always have the same rules depending on the input. So that's what's called a piecewise function. So it's a function that follows different rules depending on the input. Different rules depending on input. So for example, you might have a piecewise function that looks like this. We're going to call it f of x. And for values that of x that are less than 0, we're going to use this rule. And then for values of x that are greater than or equal to 0, we're going to use this rule. So the only thing we have to do here is we just have to be careful when we are evaluating our function, because depending on the input, our output is going to use a different rule. So let's go ahead and we'll evaluate with these options when x equals -2, 0, and 2. Okay, so starting here, starting with f of -2. Well, first we got to figure out which of the rules are we going to use. Is -2 greater than 0 or equal to it, or is it less than 0 or equal to it? It's less than 0 or equal to it. So that means we're going to use the yellow highlighted function because our input is under the category of less than 0. So let's go ahead and plug that in. 3 times -2 minus 4, that gives us -6 minus 4, so that gives us -10. So we would have the coordinate pair, -2, -10. Okay, let's look at the next one, 0. So which of these which of these rules would you follow if you're plugging in 0? Well, 0 is equal to 0, so we're going to be using the pink rule this time. So when we plug in f of 0, we're plugging it into 3 times 0 plus 1, which just gives us 1. So we have this coordinate, 0, 1. And then the last part, when x is equal to 2, well, 2 is also greater than or equal to 0, so that's still going to be our pink rule. And when we plug that in, f of 2 equals 3 times 2 plus 1, so we get 6 plus 1, which means we get f of 2 equals 7, and our coordinate pair would be 2, 7. So to recap, with a piecewise function, the math is all the same. You just have to do a little bit of sleuthing before when you're subbing things in to make sure that you are following the right rule. So your input value is going to determine which rule you're going to use. And you can have more than 2 rules. And I should have put braces around that. They usually have braces around it. Okay, cool. Next, let's talk about domain more specifically. So domain can be implied from the equation. And remember, domain is the set of real numbers for which the function is defined. So what that means is that you have to be able to get a value out of the equation if you put a value in. So if you put a particular x value, if you input that to your function, it's got to provide a y value. That's what makes it part of the domain. So let's look at a couple of examples. If I had g of x equals the square root of x minus 16, think for a second, as you look at that equation, for what values is this expression defined? Or are there any reasons that you would have to restrict values? What numbers can you put in but like don't give you a result? So for example, what happens if you put in if x equals 4? Well, if we say x equals 4 and we substitute in 4, we're going to have the square root of 4 minus 16, which is the square root of negative 12. But wait a minute, that's not a real value. The square root of negative 12 is an imaginary number. So that doesn't give us a defined output. So if we use x equals 4, this function is not defined. So what we need to do is we need to figure out, well, what are all the values for which it would be defined? The way we figure that out is, well, we think to ourselves, okay, square roots have to be positive. So we need this expression, this square root of x minus 16, we need that to be greater than 0. And all we need to do now is to solve this. So to solve it, we would square both sides to get rid of the square root, and you get x minus 16 is greater than 0. And then you would add 16 to both sides, and you get x is greater than 16. So this is the information that we need in order to restrict our domain. And what that means is our domain is now only going to be values where x is greater than, greater than or equal to, because it can be 0, greater than or equal to 16. So by using the function and noting what sort of operations are happening in the function, we're allowed to figure out that our domain is going to be only those values that will define the function. All right, let's look at another example. Say we had f of x equals 1 over 2x plus 3. So in this case, this thing here is a fraction. And what do we know you can't have in the denominator of a fraction. You can't have 0 in the denominator of a fraction. So anything that would make this expression on the bottom, anything that would make that equal 0 is not okay and would have to be restricted. Okay, it would have to be kept out of the domain because it would give us an undefined value, which then couldn't be in the range, in the output. So we can just take that denominator part, 2x plus 3, set it equal to 0, and solve. So we'd have 2x equals negative 3, and x equals negative 3 over 2. And this, if this value was our input, then we would have an undefined output. Therefore, for our domain, we're going to have to restrict that from the output. So we can say that it's all real numbers except for that thing, which we can just say the domain is all real numbers except for x cannot equal negative 3 halves. Here we would have said the domain is all real numbers such that x is greater than 16. Okay, let's do another example of finding the domain. So here we're going to have more than one thing that we have to look at because we've got overall we have a fraction. So that means we're going to have to figure out what would make our denominator 0 and restrict that. But also in the numerator, we have an absolute value. And we know that in order to take the absolute value of something, it has to be 0 or greater. So we're going to have to restrict those values as well. So let's start with our denominator. And if we set the denominator equal to 0 and we solve, we get x equals negative 6. So for our domain, we know that the first part of it is x can't equal negative 6. So we're going to have to restrict that. So x cannot be equal to negative 6 as part of, so far we can have all real numbers except negative 6. Now let's look at the numerator. And we know that in order to get a result for a square root, it has to be greater than or equal to 0. So now we're going to solve this, square both sides, you get x plus 6, greater than or equal to 0, subtract 6, x is greater than or equal to negative 6. So here, these contradict each other, right? Because in green, it says our domain would have to be all values negative 6 and higher. And from the denominator, we figured out that we can't have negative 6. So what we need to do is we need to basically combine these. And the easiest way to combine them is just say, oh, well, if x can't be negative 6, or x has to be greater than or equal to negative 6, then let's just say it can't be equal to. So our domain is now going to be x is greater than negative 6, because that covers both of those statements in one statement. Sometimes you can't do that. Sometimes you can't like combine it all together and make it all nice and neat like that. Sometimes there'll be more than one restriction and you just kind of list them. But otherwise, you try and make it as nice and neat as possible.